here with some strange symbols. So let's talk about what those strange symbols actually mean. Now that very first one, the curly braces, it actually means the fractional part. And a nice way of thinking of that is just to subtract 2, or that would be called the floor function. This is the same thing as 15 over 7 minus 2, right? Now it looks like kind of a cumbersome way to do things, but it turns out to be a useful way to represent what we call the fractional part of 15 over 7. Now this part right here, this is called the ceiling. And so it's a much easier thing to process, really. These guys right here, I think they're called Quine's corners, but this is what they call the ceiling symbol, and the ceiling of the fraction 15 over 7 is certainly just 3, excuse me. It's the largest integer. I mean, it's the smallest integer that's larger than the input argument. So notice, of course, that 15 over 7 is 2 1/7. So you always round up, irrespective of the size. You don't round up if it's 0.5 or greater. You always round up for the ceiling function. Okay, so now we have a sense on what these two symbols mean, the fractional piece and the ceiling piece. And so let's go down and see if we can do a better job solving this integral. Now, notice right here, I developed this. This is a nice little setup here. 11 over 5, for all the x's between 11 over 5 and 3, the fractional piece is just going to be exactly what we developed right here, right? And the ceiling will always be 3 in this interval, right? You pick any number x, like for example, 2 7/8 would still have a ceiling of 3 and a fractional piece of 7/8, all right? And a similar thing happens in this interval right here from 3 to 23 over 7, okay? So that suggests that we break up the integral in this fashion. All right, let me just scroll on down here. See, it's really fairly easy, really, as far as the calculus side of it. Based on this color-coded information right here, you can split the integral into 2 pieces. You have this lower limit of integration, 11 over 5, upper limit of integration, 3, and that's just based on these inequalities up here. Okay, based on these inequalities and the values that those symbols take on in those intervals. Okay. So again, this part is pretty straightforward. Now notice that if you've taken any calculus, to calculate a definite integral, an approach is to find, it's called the fundamental theorem of calculus, find an antiderivative. Now the antiderivative of this integrand would be x minus 2 quantity to the 4th all over 4. Again, that involves, it's kind of like the chain rule in reverse, but this is 4 right here. And in a similar fashion, the antiderivative for this particular integrand would be x minus 3 raised to the 5th power over 5. And one way of thinking about it, if you're familiar with differentiation, if you take the derivative of what I'm writing down right now, it's actually the integrand, and that's part of what they call the fundamental theorem of calculus, very famous result. Okay. Again, if you're familiar with the operation of differentiation, if you differentiate this, you get this. If you differentiate this, you get that. Okay. But in any event, that's how you solve these definite integrals, which actually interpret to area under a curve. Now, and y'all, that's what this very last step is. Notice that I just, on this interval, the interval from 11 over 5 to 3, we use this antiderivative and evaluated at both endpoints, as you can see right here. I just factored the 1/4 out right here, but you can see what I did. 3, I put the 3 right there. I put the 11/5 in the same spot, and the fundamental theorem of calculus says you subtract. And that's a fascinating result all by itself. And then we do the very same thing for this integral. Notice you get, actually it's an easier computation you might think, because you get 3 minus 3 right here. And believe it or not, I did this by hand. It's a very nasty calculation. I wanted to do one that was hard. Everybody does things with integer limits of integration, but it's very, very close to 1/4. This is an approximate answer right here to the question. Anyway, y'all, I like that one a lot. I hope you enjoyed it. Let me know what you think.